Hello everybody, I am Dr. Emre Süren. We continue with our exercises in our AI Agents for Penetration Testing course. I assume you followed previous lectures, that's why I'm jumping into the point now. So as you remember, in our previous exercises, we completed reconnaissance step, discovering port numbers and performing brute force attack, but our agent failed to find vulnerability in JWT vulnerability, actually in the session implementation, as well as file upload. That's why I have shown you the common failures of a typical AI agent once we don't provide relevant information, specific information. For example, scanning a port is a very general information, but when it comes to specific vulnerabilities, let's say JWT vulnerability, AI agents faces difficulties. Now, we decided to provide a method specific to JWT vulnerability. So as you remember, this is our AI agent. We are using Fire, and we are connecting our AI agent to our Kali through our MCP tool. Here, our target application, which is vulnerable JWT. Here, our Kali. On the left-hand side, on the right-hand side, this is our target. Let's refresh the page. We can access. Here, we see our requests, right? Now, I will show you what prompt we are gonna provide to our AI agent. Here, I prepared before the lecture to make things easier. As you remember, we always start to prompt our agent with a personality, or we can call it role and behavior. You are a penetration tester. Basically, we are providing this information. So we are narrowing our context. Then we provide the tools that our AI agent can access. Normally, an AI agent can enumerate environment and discover relevant MCP tools, but still here we are making sure. Third, target system. If you don't provide any information regarding the target system, you may take a default value, especially once you are just experimenting, developing a system, you will need these default settings. Why? It makes things easier. Third, you provide information regarding the methodology. So what methodology this AI agent is expected to follow. This makes an AI agent's job quite easy. So as you remember, the first step was reconnaissance, verifying the target host by using a specific tool, Nmap. I just want to tell you about one thing. This is actually not a write-up. In a write-up, we provide step-by-steps, including full commands. Here, we are providing a general information. Otherwise, AI agent is not gonna think, just follow the write-up. We don't want this because we want our AI agent to make use of this information to attack similar services. That's why, for example, you don't provide here exact IP address. Second, we are expecting our AI agent to perform port scanning to the relevant services. That's why we are providing this step. The third one, we are interested in web application. In our target system, we have 3 ports, 3 network services. What we are expecting our AI agent to focus on, start with web application. Why? As I always remind you, running an AI agent costs, right? We are burning tokens, we are burning cash, money. That's why we want our AI agent to use as less as possible to complete these tests. That's why we are providing this information, web application analysis. So we are expecting our model first retrieve the page, and we are providing the related command here. Normally, up to this stage in our previous lab exercises, we didn't provide such information. But our agent was successfully performed these actions just by querying the capabilities of the MCP server. Then our AI agent identifies a login page, decides to brute force. In our previous exercises, either we didn't provide this information, our AI agent successfully attacked to a login page and discovered the credentials. Here we are also providing some information regarding how Hydra tool can be used. In our more than 20 experiments, we identified that our agent is sometimes failing to use Hydra properly. We are providing some context information here, especially the common errors that our AI agent encounters. We provide a general comment how Hydra tool can be used here. Again, we don't have exact target IP address. If we write this, it's gonna be a write-up. We don't want to have a write-up here. We want to serve methodology. In other words, you can pretty much consider one-shot learning. We are providing just one example to remind our AI agent. Now, once AI agent discovers valid credentials, it authenticates, but authentication here is important. We are saving the cookies, right? Because we will find a vulnerability in this cookie implementation. Here, this is the information that our AI agent was failing to see, file upload. We point our AI agent now. There is a file upload feature. Please test it. Try to upload files, but try to also understand what type of files you can upload. We will keep this in mind. Then JWT token manipulation. Actually, if we ask our model how we can perform JWT token manipulation, it pretty much creates a step-by-step guideline in our prompt here. Actually, I asked our AI agent how you can perform JWT token manipulation. So this content is also generated by AI. It's not written by me. So we provide how you can discover JWT token. First, you need to access a web page so you will understand you are not able to access it. Then you will think about how you can bypass this. So here we want our model to focus on JWT token vulnerability. Once we didn't provide this information previously, our model was trying to run scanners, especially Nikto scanner. We want it to avoid, just focus on this session. We want our model to use less token as possible. Now, we also point that there are a couple of parameters inside JWT tokens. Focus on those and try to understand what does these variables do. Then we provide information regarding how JWT tokens can be manipulated, what tools can be used. So we provide the context tool information here. And we provide some information how our agent can generate keys, public-private keys. As you know, JWT tokens are signed by private keys and verified by public keys. And public keys is stored on the server. In the file upload feature, our model is expected to think that it needs to upload this public key to the remote server, because here in the ISS parameter, issuer parameter contains the URL address to the public key. Here we are not allowed to upload a CRT file, which is used for public-private keys, but it is possible to use text files, so it's gonna misuse this vulnerability. Then how to edit these cookies, we provide some information. Sometimes our model fails to use this tool. Instead, we show one another alternative, which is set. Then we show how it can access pages, which is forbidden in normal case. But once we modify the JWT cookie, how it can access. Now let's copy all this information, go back to AI agent course. As you remember, in our settings, we have a system message here, which contains some system information. We already have this information in our prompt. This is chat. First, I copy pasted everything here. Then I will try to use Google Gemini Flash 2. So we are ready, I guess. Let's press enter. This is our prompt. Now our model started to perform attacks. As you can see on the right frame, all executions successful. Now I'm coming to our output. Let's check the page, our application, post login, successful. Now brute force is successful, trying to access the get flag. Let's look at from our Kali, and we can see the responses here. It started to use sed command instead of JWT. It first tried JWT signer, probably failed to run it. Come back here. Yes. In the first try, Google Gemini 2 Flash Lite discovered the flag. As you remember, this was our flag. Now we will try another model, but not Gemini. Let's try Gemini 3 Pro preview, which is a pretty new model. As you remember, Fire has just started to support this model. Enter. This is command execution. Function call is missing. We were having the same error previously. Now I am switching to another model. Here we will start using Ollama, right? In Ollama, I will try first GPT-O's 120 billion Claude model. As you remember, Ollama started to provide this service for free. Every day we have some quota, but I guess it should work. Here are execution results, and here are the command executions. Everything is going well. Now let's look at our application. Here you see brute force attack. We are trying to see a green mark. Login successful. Not yet. I guess yes. Yes, it's green now. Now switch to Kali. Now started to save the cookies. Let's come here. We started to get errors here. Cat cookies. Cat command not found. Actually, we are providing a terminal access to our agent. That's why we are expecting our model to execute cat command. Very interestingly, it's failing. Come here. Here we haven't seen yet cat commands or similar commands. Cannot read properties, so we failed with GPT, no chat, Ollama, paste. We are going to use Kimi 2.5 Claude. Again, run. As you can see on the right hand side, so far executions are successful. Hydra started, brute force attack. Now let's see our application. We were able to perform these steps without providing that much detailed information. We were just providing our IP address. Then our models were able to perform brute force, but not beyond this. Probably we are waiting a successful right now. A green line is gonna come here. We will see. I'm coming back to my agent here. Okay, execution of agent stopped after finding the username and password. It didn't follow further steps. Now I'm going to switch to another model. As you know, previously we were having issues with fire while we are using the same session context. That's why I'm always creating a new one. Ollama. Let's try Mistral. Right now, Mistral, you know, it's a local model. It's not a cloud model. Okay, Mistral didn't perform penetration testing. It just suggested us what to do. No chat. Ollama. DeepSeek. DeepSeek cannot use tools. Error. Another model. QN. QN also couldn't proceed. Now I'm going to create new chat, paste, Ollama. GPT owes 20 billion. It was 120 billion. We tried. Now I'm gonna try a local model with 20 billion. Let's see. It stopped without writing anything. Then this is our last try. Ollama Gamma. This is also open source model from Google and it doesn't support tools. So let's wrap up. So we managed to access our flag by using Google Gemini 2.0 flashlight model, but the rest of the models couldn't succeed. As I always remind you, I have been using this model more than 2 years maybe. I cannot complain about this model. Even we are trying to use Gemini 3, it is a better model, way better model compared to 2.0. That's why 2.0 is gonna be deprecated soon. But these desktop agents, AI agents, is not super compatible using these models. That's why I have been still using 2.0. So we are done with FIRE. We have done 5 lab studies with FIRE. Now I will switch to another AI agent where we will use different models, especially we will use mainstream models like Claude, GPT, and similar models. And we will use Cursor and Claude desktop agent. See you then. I am Dr. Emre Süren.